Space is often described as elegant and orderly. Planets trace predictable paths. Stars live, burn, and die according to equations we believe we understand. Galaxies arrange themselves into vast, beautiful patterns shaped by gravity and time. But every so often, the universe breaks its own rhythm. Something appears that should not exist, behaves in a way that makes no sense, or refuses to repeat itself no matter how long we wait. These discoveries don't arrive with explosions or warnings. They emerge quietly, buried in data, noticed by careful observers, and then they linger in the minds of scientists for decades. Before we begin this slow journey through the strangest real discoveries in astronomy, take a moment to support this channel. If you enjoy calm, long-form space documentaries grounded in real science, not fiction, not clickbait, subscribe, like the video, and leave a comment sharing which cosmic mystery fascinates you most. It helps this channel reach more curious minds like yours and allows us to keep creating peaceful explorations of the universe. Now settle in. This is not a fast video. There are no jump cuts, no dramatic music, no artificial tensión. Instead, this documentary is designed to slow your breathing, quiet your thoughts, and gently guide you through some of the most baffling real phenomena ever discovered in space. Mysteries that remain unresolved even today. Everything you're about to hear is real. Observed by telescopes, recorded in data, studied by scientists, debated for years. Some of these mysteries are small and subtle. Others stretch across billions of light years. Together, they reveal something deeply humbling. We understand far less about the universe than we often assume. In August of 1977, a radio telescope in Ohio was quietly scanning the sky. The Big Ear radio telescope wasn't searching for beauty. It wasn't capturing images. It was listening, patiently monitoring radio frequencies that might reveal signs of intelligent communication beyond Earth. Then, for just 72 seconds, something extraordinary appeared. A radio signal surged from the background noise, 30 times stronger than normal, with a frequency strikingly close to hydrogen, the most abundant element in the universe and a logical choice for interstellar communication. Astronomer Jerry Emmon circled the signal on the printout and wrote one word beside it. Wow! That reaction gave the signal its name. What makes the wow signal so unsettling isn't just its strength, it's its behavior. It followed the exact pattern expected from a distant, fixed cosmic source as Earth rotated. It did not drift like local interference. It did not repeat like a pulsar. And despite decades of follow-up observations, it never appeared again. No confirmed natural explanation fully accounts for it. No second detection has verified its origin. It remains the most intriguing signal SETI has ever recorded. Not proof of intelligence, but not easily dismissed either. A single cosmic whisper, then silence. Most stars behave in predictable ways. They brighten, they dim, they pulse with regular rhythms that astronomers understand well. Tabby star does none of this. Also known as KIC 846-2852, this star appears ordinary at first glance. It's roughly the size and temperature of our sun. Nothing about it should be unusual. But when astronomers studied its brightness over time, they noticed something deeply strange. Instead of small, periodic dips caused by orbiting planets, Tabby star experiences irregular, dramatic drops in brightness, sometimes by more than 20%. No planet could block that much light. No consistent cycle explains the timing. No known stellar behavior matches the pattern. At one point, even serious scientists briefly considered exotic ideas, not because they wanted to, but because nothing conventional worked. Over time, dust clouds and debris have become leading explanations, but even those models struggle to explain all observed behavior. Tabby star reminds us of something important. Not every mystery vanishes when we collect more data. Some simply become more complex. In astronomy, perfection is rare. Stars are messy. Galaxies are distorted. Nebulae twist and fracture. That's why odd radio circles, ORCs, are so unsettling. Discovered only recently, ORCs are enormous, perfectly circular rings visible only in radio wavelengths. Each one spans hundreds of thousands to over 1 million light-years across. They don't glow in visible light. They don't align with known galaxy clusters. They appear suddenly in radio surveys, floating like silent halos in deep space. Only a handful have been found so far. No single theory fully explains them. They don't resemble supernova remnants. They don't match known black hole jets. Their symmetry suggests powerful, centralized events, but their scale defies easy explanation. ORCs are reminders that the universe can still surprise us in entirely new ways, even with modern instruments. According to our best cosmological models, the universe should look roughly the same in every direction when viewed on very large scales. This idea is called the cosmological principle, and it underpins much of modern astronomy. Then astronomers found the giant arc. Stretching across billions of light years, this massive arrangement of galaxies appears far too large and too organized to fit comfortably within existing models. Not long after the Big Ring was identified, another immense structure, circular in shape, equally vast, equally puzzling. These formations challenge our assumptions about how matter should be distributed across the cosmos. They may hint at unknown early universe processes, or they may suggest that our statistical expectations need revisiting. Either way, they remind us that even the largest patterns we trust may be incomplete. Space is mostly empty, but some regions are shockingly empty. The Boötes void is one of the largest known voids in the observable universe, spanning roughly 330 million light-years. Within this vast bubble, galaxies are almost entirely absent. Imagine traveling hundreds of millions of light-years and encountering almost nothing. No clusters, no bright spirals, just darkness and sparse matter. Voids exist naturally in cosmic structure, but the Boötes void is extreme. Its size pushes the limits of what simulations predict. Its emptiness raises questions about galaxy formation and large-scale evolution. Sometimes, what's missing tells us more than what's present. The cosmic microwave background is the oldest light we can observe, a faint afterglow from just 380,000 years after the Big Bang. It's remarkably uniform, except for one region. The CMB cold spot is an area of sky that appears significantly colder than surrounding regions, and far larger than random fluctuations should allow. Some suggest it's caused by a massive supervoid. Others wonder if it reflects physics beyond the standard model. It may even be a statistical anomaly, but one that stubbornly refuses to fade with better data. A subtle imperfection frozen into the universe's earliest light. When astronomers analyze starlight, they decode chemical fingerprints. Most stars contain predictable elements: hydrogen, helium, heavier materials forged in previous generations. Przybylski's star breaks those rules. Its spectrum shows signs of short-lived radioactive elements, substances that should decay in years or decades, not persist for over half. It's a star that challenges our understanding of stellar chemistry and nuclear processes. In 2017, something unfamiliar swept through our solar system. Oumuamua was the first confirmed object from another star system ever detected passing through ours. It showed no visible coma like a comet. It accelerated without obvious outgassing. Its shape, possibly elongated or flattened, remains debated. Every explanation fits part of the data, but none fit all of it perfectly. It came, it passed, it left, and we were left wondering what else moves silently between the stars. In 2018, astronomers observed a brilliant explosion called it 2018 Cow. It brightened incredibly fast. It glowed blue hot. Then it faded within days. This behavior didn't match supernovae or gamma-ray bursts. It forced scientists to define a new category: fast blue optical transients. These events are rare, violent, and poorly understood, possibly linked to newborn black holes or extreme stellar collapses. They remind us that the universe still has explosive surprises left. HD 140283 nicknamed the Methuselah star, is a nearby, ancient star. Measurements once suggested it might be as old as, or even older than, the universe itself. While uncertainties likely reconcile the numbers, the fact that it comes so close exposes the limits of our dating techniques. It's a quiet reminder that even our timelines rest on fragile assumptions. These mysteries are not failures of science. They are invitations. Each one shows us where knowledge ends and curiosity begins. They slow us down. They humble us. If you've reached this point, thank you for sharing this quiet journey through the universe. If this video helped you relax, focus, or wonder, subscribe, like, and share it with someone who loves space as much as you do. Now breathe slowly and let the universe remain strange.